Before plant nutrients were scientifically identified, growers knew some materials helped plants prosper. Early farmers probably noticed the lush of grass around animal droppings and began using them to raise better crops. Lime, ashes, dead fish, ground bones, and bird and bat guano have all been used. Even human waste, night soil, have been an important fertilizer in some cultures. Most American growers now use fertilizers to supplement the elements their crops need. I'm Dr. Busk, and in this video, I'll discuss forms of inorganic and organic fertilizers. Fertilizer is material applied to soil or plants to supply essential elements. Some states legally define minimum requirements for material to be sold as fertilizer. Fertilizers can be grouped into 4 categories: mineral, organic, synthetic organic, or inorganic. Mineral fertilizers are ground rocks containing nutrients. Dolomitic lime, for example, is a fine source of calcium and magnesium. Most minerals have low nutrient content and dissolve very slowly, so their usefulness as fertilizers is limited. Organic fertilizers are organic materials such as blood meal that contains nutrients. Many can be considered slow-release fertilizers because nutrients are released slowly over the growing season as the organic matter decays. Synthetic organic fertilizers are manufactured by industry but are chemically organic, contain carbon and nitrogen. Urea is readily available to plants, but others, mostly urea derivatives, are made to be slow release. Nutrient content is generally high compared to mineral and natural organic fertilizers. Inorganic fertilizers are mined and processed or manufactured and are chemically inorganic. Most dissolve quickly in the soil for rapid growth response, initially joining the nutrient pool in the soil solution. Fertilizers are provided or applied in a number of forms, giving growers several choices of application methods. The forms can be divided into 4 main groups: pressurized liquids, fluids, dry fertilizers, and slow-release fertilizers. Anhydrous ammonia, a pressurized liquid, is injected into the soil through chisels. The ammonia dissolves in soil water to become ammonium ions. Fluid fertilizers are also liquid, but they are not under pressure. The most common fluid fertilizers are solutions. Dry fertilizers are applied to soil where they dissolve quickly in soil water to release nutrients. Dry fertilizers are available in 3 types. Pulverized fertilizers are made by crushing fertilizer materials into a powder. They are dusty, making them unpleasant to handle or spread evenly, so are not the preferred form. Granules are much easier to use. The manufacturer treats the material so it has large, more evenly sized grains. Granules spread evenly and easily with much less dust. Prills are smooth, round, and dust-free. Slow-release fertilizers are also dry. The nutrients they contain dissolve into the soil solution slowly over a period of several weeks up to a few months. Slow-release fertilizers are too costly for common agricultural use, but they are widely used in horticulture, for example as turf fertilizers. Slow-release fertilizers work in one of 2 ways. Some are made of large nitrogen-containing molecules that break down slowly under the influence of water and microbes. Others are simply small granules of regular fertilizers coated with plastics or sulfur. These slowly release nutrients as coatings thin, soften, and crack when exposed to water. Products are manufactured to different release rates, but in practice, rates vary depending on the temperature, moisture, and biological activity they are exposed to, and tend to release nutrients more rapidly at first. They work best if it incorporated into the soil rather than left lying on the top of the soil or potting mix. While cost is a drawback, they present a number of advantages: a reduced need for repeat applications, delivery of nutrients at a rate plants can use them, limiting adverse effects of the environment, and reduced chance of fertilizer burn since only a small amount of fertilizer is released at any one time. Few fertilizers are pure elements. Rather, most consist of compounds that release nutrients in forms useful to plants. These compounds are called nutrient carriers. Organic nitrogen exists in several forms. Decay changes the organic nitrogen to ammonia, which in turn changes to nitrates. Many organic nitrogen sources are too expensive for farmers and are used primarily by home gardeners. However, some sources, such as manure, continue to be used by many farmers. The first commercial nitrogen fertilizer was actually organic: seabird droppings or guano, harvested in Peru. Today, fertilizer companies manufacture most nitrogen carriers from ammonia produced by the Haber-Bosch process. The Haber-Bosch process, one of the more monumentous of human inventions, was developed by a pair of German chemists in the early 20th century. The Haber-Bosch process fixes nitrogen from the air by attaching hydrogen atoms to it from natural gas. This reaction, in the presence of heat, pressure, and an iron catalyst, produces ammonia. Ammonia can be used as fertilizer or changed to other forms, as shown in the figure on the left. Anhydrous ammonia, consisting of 82% nitrogen, results directly from the Haber-Bosch process. The word anhydrous means without water. Anhydrous ammonia is the cheapest, strongest form of nitrogen. Ammonium nitrate, containing 33% nitrogen, is half ammonium nitrogen and half nitrate. This is a good general-purpose dry material that is easy to handle and apply. Ammonium sulfate, consisting of 21% nitrogen, also contains sulfur. It is a dry fertilizer. Ammonium sulfate is very acidic forming and is ideal for acid-loving plants. Nitrate of soda, sodium nitrate 16% nitrogen, is commonly used on tobacco. Unlike most other nitrogen sources, it raises soil pH. Urea, containing 46% nitrogen, is a synthetic organic material. In soil, urea breaks down to ammonium nitrogen. A popular dry fertilizer, perhaps the most widely used nitrogen fertilizer, it can be produced more cheaply than ammonium nitrate. It is also used to make fluid fertilizer. Urea formaldehyde, UF, isobutyldiene urea, IBDU, and sulfur-coated urea, SCU, are slow-release synthetic organic materials. They are used primarily to fertilize turf grass and potted plants. They are too costly for general agriculture use. Phosphorus fertilizers are obtained from surface mining of rock phosphate in Florida and other locations. Rock phosphate was deposited during geologic time under shallow seas. Phosphate rock contains various apatite minerals, which are calcium phosphate materials. The ground rock can be applied directly to the soil, but is usually treated with acid to break down the apatite into simpler compounds. Bone meal and manure are both organic sources of phosphate. Bone meal is made by grinding bones that are a byproduct of the meat packing industry. Homeowners use bone meal as a phosphate and calcium fertilizer. Rock phosphate, a rock powder containing between 25% and 35% phosphate and calcium, may be spread on the soil but will dissolve slowly. Rock phosphate works best when finely ground and used on acid soils and is commonly used in organic growing. Superphosphate, containing 20% phosphate, results from the reaction of rock phosphate with sulfuric acid. Being lower in phosphate than other carriers, it is no longer used by most growers. Triple superphosphate with 46% phosphate is also treated rock phosphate. It is higher in phosphate than regular superphosphate and contains less sulfur or calcium. Triple superphosphate is a popular fertilizer. Both superphosphates contain small amounts of fluorine, making them unsuitable for many potted foliage plants highly sensitive to fluorine. Neither is water soluble enough to make up a solution. Ammonium phosphates are made by mixing phosphoric acid with ammonia. Two similar products result, monoammonium phosphate and diammonium phosphate. Both are much more water soluble than superphosphate compounds and are the products of choice in applying phosphorus in fluid form. They are also used in dry fertilizers. Potash is mostly mined in deep mines from deposits laid down in geologic time by evaporating shallow seas. Some is harvested in gigantic evaporation pans from evaporating bodies of water such as the Great Salt Lake of Utah and the Dead Sea of the Mideast. Canada supplies the greatest amount of the world's potash. While we speak of potassium as a plant nutrient, when referring to fertilizers, the term potash is commonly used. This older term derives from an original source of potassium oxide in pot ashes. No fertilizers actually contain potassium oxide. In the following listing, the viewer will notice other archaic terms still in common use, such as muriate of potash. Muriate of potash, potassium chloride, containing 60% potash, accounts for 97% of all potassium fertilization. It costs less than other carriers and dissolves readily in water. Because it contains chlorine, other sources may be better for crops sensitive to chlorine. It is also highly saline. Sulfate of potash, potassium sulfate, contains 49% potash and is used to a minor extent in dry fertilizers for crops sensitive to chlorine, or where the saltiness of potassium chloride is a problem. Nitrate of potash, potassium nitrate, contains 13% nitrogen and 44% potash. It is a common fertilizer for container plants. Although it is mostly used in dry form, it can also be used in solution. Sulfate of potash magnesia is also useful for chlorine-sensitive crops and where soil salinity is a problem, and consists of 22% potash, 11% magnesium, and 22% sulfur. Wood ashes and manure are also good potash sources. Granite meal is a rock powder used by some growers who prefer not to use chemical fertilizers. This material is a finely ground, gritty waste product of the monument and building stone industry. Green sand is another rock product derived from certain sedimentary deposits and used for inorganic growing. Mineral fertilizers supply most of the calcium, magnesium, and sulfur required by plants. The most important fertilizers include lime, dolomitic lime, gypsum, and sulfur. The finer the ground, the more quickly these materials act. Many of the minerals, but not gypsum, affect soil pH. The table lists several sources of secondary elements. Each trace element is available in a number of chemical forms. Most trace elements, however, are commonly used in the following forms, which are summarized in the table. Sulfate salts are inexpensive and dissolve easily in water. They can be used as dry or fluid fertilizers. Trace elements are also available in other types of salts and oxides. Fritted trace elements, FTEs, are a safe way to apply trace elements. FTEs are made by adding salts to molten glass, which is poured onto cold running water. The glass cools and shatters. The pieces are then ground into a fine powder. Frits are dry fertilizers that act as a slow-release source of micronutrients. Chelates are common, useful, water-soluble trace element fertilizers generally used in fluid form. In conclusion, fertilizer is a substance used to supply essential elements to crops. Fertilizers may be finely ground minerals, natural or synthetic organic materials, or inorganic chemicals made by industry.